Hi friends, welcome back to the channel. This video marks the beginning of a new series on a very important topic of bolted joints. We will also talk about different types of screws, fasteners, and most importantly the mechanics or the physics that governs the operation of these very important design elements. Let us start with this particular phrase that we often come across, nuts and bolts. So this particular phrase refers to the very basic details or the nitty-gritties of a certain system. The importance, even though these elements appear as very small in size, their importance is huge. In a nutshell, it's an important part of the design. The bolts, the fasteners, they form an important part of the design. To re-emphasize this point, let me draw your attention to this particular news article. As you can see here, broken bolt does damage at Seabrook. So what happened there was, this bolt which was fastened to the pump, it gets loosened from the pump due to vibration loads, and which in turn gets into the reactor along with the coolant, and it results in the damage of three nuclear fuel assemblies, and subsequently it caused a lot of financial burden as well. So this is just an example where a poorly designed fastener caused havoc. And another important point you usually come across is that Boeing 747 uses around 2.5 million fasteners. So this just tells you about the relevance of this particular topic. So too much of introduction. Now let's get into the content that I will cover as a part of this lecture series. So here I have scribbled down the 5 important topics that I will cover as part of this course. So the course will initially start with discussion of standard thread forms. Then we will move ahead to power screws. Then comes the most important topic of threaded fasteners and how they are utilized in pretension bolted joints to hold two things together. And to the fag end of the course, we will also discuss about the joints, bolted joints and shear also. So that forms the course. And in between, needless to say, we will be solving problems because that makes you prepared for the future or your profession career. Before we dive into the discussion of thread forms, screws are mainly used to for two applications. One is to hold things together, and at times to transmit power or motion. A good example to the second category is the lead screw in a lathe. Here I have a few images of the same. So as you can see over here, we have a bolted joint which holds these two flanges together or components together, and here we have a screw which holds these two components together, and on the right we have the lead screw from a lathe. Make sense? Now coming to the discussion of standard thread forms, here I have shown you a thread profile. There are so many terminologies that we come across when we talk about a thread form. So let's start by discussing one after the other. For the first one to discuss is the included angle. So from this figure itself, it is obvious. If I ask you what will be the included angle for a thread profile, most probably you will tell me probably that will be this particular angle. So this particular angle, this is the included angle, right? So this is usually 60 degree for standard thread forms. Okay, now moving to the next, what will be the diameter of this particular thread form? Now when we talk about thread diameter of a particular thread form, there are a couple of them or more than couple of them. So the first one and the most important is the nominal diameter or the major diameter of a thread form, which is the largest diameter in this particular thread form. So if I ask you to draw which is the largest diameter, the largest diameter will be this one. So this is your major diameter or nominal diameter. Okay, then we have something called the minor diameter or the root diameter, which I am showing currently. So this is your root diameter. This is the minimum diameter in a standard thread form. Okay, so this is called the root diameter or the minor diameter, and this is called the major diameter. Then we looked at included angle as well. Another important terminology with the standard thread form is pitch. So pitch, as shown over here, is the distance between two adjacent crusts or troughs. So this top portions can be called as crest and the top portions can be called as troughs. Sorry, the bottom portions can be called as troughs and the top portions can be referred to as crests. So this one is your pitch. So we have already seen two diameters. There is another one which is called the pitch diameter, but I won't give you the definition as such. I will tell you what is the relevance of pitch diameter, then we will talk about it in detail. For the time being, just understand that pitch diameter comes in between your minor and major diameter. So if you ask me to draw, it will be somewhere here. So this particular thing will be your pitch diameter. Okay, I will come to that point after a while. Then threads can be external or internal, makes sense because we come across both of these types very regularly at work. Then the standards, it is slightly important. In US, I think they follow this unified national standards, and in India, we follow metric standards or ISO standards. That doesn't make a lot of difference in the physics or in the mechanics that govern these elements, but it's better to know there are two different standards prevailing in different countries. Okay, so we saw all these important terminologies. We saw what is an included angle. We saw what is nominal diameter. I showed you what are crests, what are roots, then minor diameter, pitch diameter. Pitch I explained you. Now there is something called lead. So once you rotate a screw or a bolt by one complete rotation, what is the amount that this particular bolt advances in one direction? So that is called the lead. For single start threads, your pitch and lead are the same. So you may be asking me, what is single start threads? Hold on, I will explain that in a minute. But among all these terminologies or the nomenclature, what is most important? Because what do you use to specify a particular standard thread form? It is this particular quantity, nominal diameter and pitch. So these are the two important quantities that we use to specify a particular standard thread form in metric standards. I'll come into the details of how threads can be specified in each of these standards. Make sense? Then there are small alterations in the profile. For example, I can show you one here. This one. It's like this is from the Unified National Standard. They call this profile as the UN profile, Unified Nations, and then this is I think UNR. So what is the difference here is here you can see at the crest you have a fillet, you have a rounded fillet here. Okay, but here it is not there. So there are some basic changes in the profile depending upon what kind of thread series they belong to. Okay, hold on a minute and think what will be the advantages when you have a rounded fillet here. So this is your UNR. Uh, When you have a rounded fillet, the stress concentrations will be less and that will give you an improved fatigue strength. Why so? Because when you compute fatigue strength of a particular component, the stress intensity factors will come into play. That's the topic for an entirely different segment. So for the time being, let's move on. A little while ago, I talked about the lead and its relation to the pitch. Now I'm talking about multiple start threads, double start threads, triple start threads, or single start threads. So I have shown here three diagrams. So the difference is it's as good as thinking like you have two strings attached to a pencil, okay, that are running parallel to each other. So here also, when you have multiple start threads, there will be multiple threads which will run parallel across the shank. So the importance or the advantage you get with this kind of thread forms is that faster advancement of the thread, because for one turn of the thread the amount by which you will advance will be 5 times the pitch for a 5 star thread. Similarly, it will be 2 times the pitch for a 2 star thread. So that's the advantage you get with multiple start threads. Okay, so now moving ahead. Then depending upon the pitch also there are thread series classifications that I want to just tell you. So depending in Unified National Standards or as per UNS standards, we have three classifications. The first one is the UNC course, then UNF fine and UNEF. So these are the different categories depending upon the pitch, whether it is fine or coarse or extra fine, and it goes like this. Similar to that in ISO standard also we have two classifications. One is the fine and the other one is the coarse. I have a question for you. Which one you think will be much stronger, whether the fine or the coarse? I will give the answer towards the end of this video. For the time being, let's look at what are the differences between a coarse thread and a fine thread, and for what kind of applications we should use a fine thread. So here I have listed down one after the other. For ordinary applications, we can live with coarse threads. And when you have repeated insertion and removal, it is preferred to go for coarse threads. And moreover, in applications where it is screwed to a softer material also, it is better to go with coarse threads. Now, what are the advantages of fine threads? They are resistant to loosening from vibration and they are used in automobiles and aircrafts and etc. Because in automobiles and in aircrafts, the joining members or the fasteners are subjected to severe vibration loads. Make sense? Let's move ahead. Depending upon the type of the tolerance also, there are different classes of fasteners, class 1, class 2 and class 3. This is coming from UNS standards. Now we need to respond to this very important question: how a thread is specified. Because when we discussed about the thread form, there were a lot of things. There were major diameter, minor diameter, pitch diameter, lead, all those things were there. Now you should understand in each standard how a thread is specified. First we will start with the Unified National Standard. Here we will specify the series, the diameter, the pitch and the class of the thread. So for an example, take this. So this is how a particular thread form is specified as per UNS standards. So this tells you what is the diameter and this tells you what is the number of threads per inch, or in other words it gives you the information regarding the pitch. Then UNC's which series it corresponds to a core series. Then 2 is the class of fit and A corresponds to external. It's an external thread. So makes sense. Now let's move ahead and see how you specify a thread in metric standards. In metric standard, it's far more easy. We call it M18 cross 1.5, where M refers to metric standard and 18 refers to the nominal diameter. What is nominal diameter? It is the major diameter, maximum diameter in a thread form. So 18 is the nominal diameter and 1.5 is the pitch. Make sense? Let's move ahead. Then mostly we come across with right hand threads. What are right hand threads? By right hand threads, we mean that when you rotate the thread in a clockwise direction, the thread advances or the screw advances towards the nut or away from you. Make sense? Last but not the least, I need to tell you about a very important concept of tensile stress area. And a while ago in this video itself, I told you I will tell you the significance of pitch diameter. Pitch diameter. So now it's the right time. You take an unthreaded rod like this, it's an unthreaded rod, and then you have a rod which is threaded like this. Now you compare the tensile stress or the tensile strength of both these things, and you need a bar, you need an unthreaded bar which is having the same strength or as that of this threaded bar. Then you should choose the diameter of this particular thing, this particular unthreaded bar, in such a way that this diameter of the unthreaded rod is equal to the mean of your pitch diameter plus mean of your pitch diameter and the minor diameter. Mean is simply given like this. So make sense? So that is the tensile stress area of a particular fastener. You can't expect the thread form to behave as an unthreaded rod which is having a diameter of which is having a diameter equal to your nominal diameter, because in a threaded form you don't have material over here. Make sense? So it is well below your nominal diameter, but it is above your minor diameter, because there are some more material which is protruding from the diameter corresponding to the minor diameter. So that's why your pitch diameter is well within your minor and major diameters. So if I want to put that in some form, I will say dp is less than your major diameter, but it is greater than your minor diameter. Make sense? So this brings to an end of this first video. So in this video we talked about various terminologies referring to the screw threads. Then we talked about the different types of thread classifications depending upon the pitch, depending upon whether it's a multi-start thread or a single start thread or a double start thread. And then we talked about different standards that is prevailing in different countries. Then we went ahead and talked about how to specify a particular thread, and towards the end we saw the very important concept of tensile stress area of a particular fastener. Thanks for watching.